All right. So now, since we know what is a random experiment and what is its associated sample space, we'll talk about random variable. Right now, you have the basics behind this, so now we can move forward it. So coming directly to definition of random variable, uh, so random variable is a variable whose possible values are numerical outcomes of a random experiment. So it is more about numerical outcomes for any given random experiment, right? Or in other words, you can say that the random variables are methods for turning possibly non-numerical outcomes of a random experiment into numbers, right? Uh, so let's look at some examples to make this more clear. You remember, right? We did talk about an experiment of tossing a coin. So it's a random experiment, yes or no? Yes, it's a random experiment because we don't know what kind of outcome is going to come, right? So there is always an uncertainty involved to it, and its sample space would be head and tail, which is uh, the list of all possible outputs, outcomes from this experiment. So if we have to talk about one of the possible random variable attached to this experiment, it could be number of heads when you toss a coin, right? So how many heads you can get when you toss a coin single time. So it would be either 0 or 1. So this random variable, which denotes uh, by number of heads when you toss a fair coin, it would be either 0 or 1. So these are the possible values for this random variable. So you can see how we have converted the sample space, which is h and t, into another variable called random variable, which has more numerical outputs attached to it. Let's look some more examples. So what if you roll a dice together? Uh, so if then you can see, can understand that there are 36 possible combinations. So either you get 1, 1 on both of them, or 1, 2, 1, 3, 1, 4, and so on, right? So likewise, you can get 36 possible combinational outcomes. So, and you can see the sample space. So, as we discussed right now, right? So, this is a random experiment, and this is a sample space. What do you think? What kind of random variable can be there for this kind of experiment? Remember, random experiment uh, random variable should have a numerical output, right? So, maybe this, I mean, there could be multiple random variables attached to a random experiment, but for this case, uh, one of the random variables associated with it would be sum of outcomes from two dice. So whatever number you get in each of them, you just sum it up, and then uh, that is your outcome. So if I have to ask you, what do you think? What all values this random variable can take? So its range would be 2, which is like 1 plus 1, 3, 1 plus 2, or 2 plus 1, 4, 2 plus 2, 1 plus 3, 3 plus 1. So these could be the only possible combination. Some numbers would be available with this experiment, right? Let's look more examples. So if you remember, we discussed few examples of random experiment, right? So uh, let's see what all random variables can be attached to those. Number of defective products. So earlier we had experiment whether the product is defective or non-defective. That is the sample space. But this is a way to define random variable, like number of defective products. It could be 0, 1, 2, 3, right? Similarly, we talked about what kind of weather it would be, rainy, sunny. So one of the random variable attached to it would be number of days it will rain in a month. 0, 1, 2, 3 uh, can go to 30 when it rains all over the month. Similarly, uh, For the example of survey of customers. So that is this is how you can define a random variable if they how many customers liked product A to 0, 1, 2, 3. So I hope you were able to understand the distinction between a random variable and an outcome and a sample space of a random experiment. So random variable is a way to define numerical outcomes from a random experiment. Cool. Thank you.